This is the 6.08 lesson, Calculating Yields of Reaction. Determining the amounts of products that you can get from a reaction, or the amounts of reactants you need, is the goal of stoichiometry. Chemists use the information in chemical reactions to answer questions about quantities of reactants and products. Here you will continue applying what you have learned about stoichiometric calculations to various situations. Goals for this lesson: calculate the masses of reactants and products in a chemical reaction when given the mass of the reactant or product and the relevant atomic masses. Goal number 2, determine amounts of reactants and products when given balanced reaction equations. The amount of chemicals is found by conversion factors or fractions. It's found by relating mole-volume relationships, chemical equations, specifically the mole ratios, and the molar mass, or the mass of 1 mole. Again, we are seeing the magic of the mole. Here is your student guide. Stoichiometric calculations involve many steps. To calculate amounts of reactants or products, you need a balanced chemical equation, a periodic table, and one known quantity. Step 1, balance the given chemical equation. Again, I've kind of glossed over that because they're giving it to you balanced so far, but it has to be balanced so you have the correct ratio. Step 2, find the appropriate mole ratio from the balanced equation, whether it be product to reactant, reactant to product, reactant to reactant. Convert the given quantity from units, molecules, mass, volume, to moles. If you are calculating products from reactants, you may need to determine which reactant may be limiting. Step 5, use the given molar quantity and the mole ratio to find moles of the unknown quantity. Step 6, convert the moles of the unknown quantity to the desired units, molecules, mass, or again, volume. Limiting reagent. So this problem says if you have 10 grams of dinitride and 10 grams of dihydride, which is the limiting reactant? Okay, so we're going to use our mole ratio, which says for every 1 molecule of N2, we need 3 molecules of H2, but beware, they're giving you grams. This is moles. You have to do some conversion first. You can't just look at this problem and say, oh, I know the answer because I need 3 times as many hydrogen, and look, they're 10 and 10 grams. It does not work that way. You actually have to figure out the math. So step 1, is the equation balanced? And it is. Step 2, they're going to have you convert to moles. And I agree. I would do it the same way. I don't know why there's a percent sign here. I'm guessing it was just a weird typo. It should be a multiplication sign. So they said 10 grams divided by 28 is 0.36 moles of dinitride, and 10 grams divided by 2 is 5 moles of dihydride. Okay, so again, let's go ahead and see how they got that. So we have 10 grams of N2, 10 grams of H2, and so same thing we always do. We start out with what we know. We know we have 10 grams of hydrogen. We make it a fraction, put it over 1. What has to go on the bottom of our next fraction? It has to be grams of hydrogen. And again, we want to convert to moles. Moles are magic. So in 1 mole, how many grams are there? Well, it's not just hydrogen, but there's H2. That's very important, H2. So that means there's 2 of them. They're each 1, and so we'll just say that it's 2 grams. Again, going to hundredths is better. I know in the example they show you whole numbers, so we'll use it for this one. All right, and so for our nitrogen, we start out with 10 grams. And sorry, that's supposed to be a 2. And what has to go on the bottom of my next fraction? Grams of N2. Again, we're changing it to the magic mole. And how many grams? Well, if each nitrogen is 14 and there's 2 of them, then it would be 28. All right, so put it in your handy dandy calculator and we have 5 moles of H2, and we have 10 divided by 28 is 0.36 moles of N2. So here you can really see what I was talking about at the beginning, that you can't just say, oh, 10 and 10 and go from there. No, 10 grams of hydrogen is 5 moles. 10 grams of nitrogen is about a third of 1 mole. So it's a huge difference. All right, so now we want to go back to our equation, and we want to find out which one is the limiting. All right, so let's start with hydrogen since it's on top. And so 5 moles of H2. And if I have 5 moles of H2, I want to know how many moles of N2 I'm going to need for this reaction. So what has to be at the bottom? Moles of H2, because it's got to cancel. And so I want to see how many moles of N2 there's going to be. And so I look at my equation, how many moles of N for every 3 moles of H2? 1. And then the number on the bottom is 3. So put it in your calculator. 5 divided by 3 is 1.67 moles of dinitride. So that tells us how much we need. If I'm using 5 moles of H2, I need 1 2/3 moles of N2. Do I have that? No, I don't. I don't have that. Therefore, N2 is my limiting reactant. I don't have enough of it. All right. Now, in the lesson, they actually checked the other one out for us, which is kind of nice. You can see both. Maybe, if it wants to let me show you both. All right. So again, it's balanced. We converted them both to moles. We found the mole ratio. We calculated the moles. So they started with the nitrogen, and they said, okay, I have 0.36 moles of dinitride. Again, use your ratio, and this should be a multiplication sign. And they got 1.08 moles of H2. So calculation shows that 0.36 moles of dinitride would combine with 1.08 moles of dihydride. You have 5 moles of H2. Thus, there is an excess of H2, and the limiting reagent is N2. So you can see you can start with either of the reactants once you get to the mole stage to see if you have too much of the other one. And that's how you find the limiting one. So again, put in your notes what you need to put in your notes. I'll put this screen back up. You can hit pause if you need to. All right. So, amount of methanol produced. If you react 112 liters of hydrogen gas in excess carbon monoxide at STP, how many liters of methanol will you make? All right, so again, we have to have a balanced chemical equation. They're giving that to you, and from there you can go ahead with your problem. All right, so first things first, write down what we know. So what do we write down first? 112 liters of hydrogen gas or dihydride. Again, make it a fraction over 1. So what has to be on the bottom of my next fraction? Liters of H2. And of course, even though we want to get to liters of methanol, we want to convert from one compound to another compound. And how do we do that? The magic of the mole. So we need to know moles of H2. And in 1 mole of any gas at STP, how many liters are there? 22.4. Okay, what has to go on the bottom of my next fractions? Mole of H2. And now I can convert into the chemical I need. All right, so if you're reading this and you're like, which one's methanol? So let's read it again. If you convert 112 liters of hydrogen gas in excess carbon monoxide. So if you did not know carbon monoxide was this one, the fact that we're reacting it together should have told you, oh yeah, they're talking about the reactants. So they want to know how many liters of the product are you making. And make is your other clue that it's going to be one of the products. All right, so let's look at our ratio. So here's our hydrogen, here's our methanol. What's our ratio? It's 2 to 1. What number goes on the bottom? The 2, because that's the dihydride, and the 1 goes on the top. All right, so now what has to go on the bottom of my next fraction has to be moles of CH3OH. And what am I converting to? Liters. So again, 1 liter of any gas at STP is 22.4. Okay, so let's go back, make sure we crossed off liters of dihydride. We changed to the magic of the mole. We did a mole ratio to change to a different chemical. We ended up with liters of CH3OH. Okay, I'm done. I can put it in my calculator. So in my calculator, I'm going to put 112 times 1 times 1 times 22.4, do the bottom, divided by 22.4. Yes, I do know that those cancel. And then divided by 2, and your answer is 56. So 56 liters of what? CH3OH or methanol. Again, hit pause, make sure you have everything that you need. All right, next problem. You need to make 360 grams of lithium hydroxide. How many grams of lithium nitride are required? Assume you have excess water. All right, so what do you write first? You're going to write down what you know, which is the 360 grams of LiOH. You're going to put it over 1. What has to be on the bottom of your next fraction? Grams of LiOH. And we're going to convert to grams of a different chemical. We're going to a different chemical, so what do we need? We need the magic mole, but we can't just go directly there. We have to get moles of the chemical we have first. So in 1 mole, how many grams of lithium hydroxide are there? Well, lithium is about 7. Hydrogen is about 1. And oxygen is 16. So let's add that up. 16 plus 7 is 23, plus 1 more is 24. So there's 24 grams per mole. And now we are in moles, so we can put what at the bottom of my next fraction? Moles, but specifically moles of lithium hydroxide. And what chemical am I converting to? I'm going to be converting to moles of Li3N. And so let's look at our balanced chemical equation. And what's the mole ratio? It's 1 to 3. And which number goes on top? The 1. And then the 3 goes on bottom because that's the lithium hydroxide. And what has to go on the bottom of my next fraction? It has to be moles of lithium nitride. And what am I converting to? What's my final unit? Grams. All right, so I want grams, again, of lithium nitride. And how many grams are in 1 mole? Well, there's Li3, so 3, so 7 times 3, plus nitrogen, which is 14, which is 35. Put it in your calculator, and you are going to get 360 times 1 times 1 times 35 divided by 24 divided by 3, and your answer is 175 grams of Li3N. Again, hit pause and copy what you need.